Good morning, everyone. It's lovely to have you joining us for our Stock and Waterways webinar today. To get things underway, I'd like to acknowledge that we're meeting on Ngunnawal country this morning, and we'd like to pay our respects to elders past, present, and to emerging leaders. It's a pleasure to have you joining us, and this morning Laurie is going to take you through some of the key principles relating to stock and waterway management and why it's so important to look after our waterways. So without further ado, Laurie, would you like to share your screen, please?
Sure.
Thanks, Laurie. You can take it away.
Thank you. I'll just launch the slideshow. Well, thanks everybody for coming along. It's really nice to see so many people interested in this topic. But what I thought I would start by doing is defining what a riparian zone is, because I think in river management, we often assume that people know what we're talking about. So a riparian zone is any bit of land that adjoins or is influenced by a waterway of any description. So that could be a small ephemeral gully, it could be a creek, it could be a river, it could be a wetland, a swampy meadow, or any other area that is influenced by water. So some of the reasons that we want to manage stock around waterways and manage waterway issues, there's more than what you think. I mean, we all know sort of things like improved water quality by maintaining ecosystem function, because all of those processes result in clean water. But things like retaining nutrients in that riparian area, habitat for wildlife, things like our fish, which have significantly declined over the past 100 years in the Murray-Darling Basin, things like algal blooms where we've got too much phosphorus going into the water, and cattle are particularly bad for that. As Shawan pointed out, someone did their PhD on cattle that stand in water poo 5 times more than when they're not standing in water. Sounds like an interesting PhD. And I had a bit of a chuckle about it, but the significance of that for people like us managing rivers is actually quite important. Things like minimising soil loss and land loss on properties, managing stock more broadly so they're not as prone to disease when they've got a well-managed water source. Biodiversity, wind shelter, creeks and rivers are often located on farms in places that actually provide shelter to paddocks if they're managed properly. Salinity, just to buffer the river from the effects of salt, and things like increased capital value because they look nice and they're nice places to be. So there's a broad range of reasons why we want to manage our rivers, and some of the photos there down on the left bottom is the Boorowa River, where there's lots of areas of the Boorowa that aren't looking like that. The top one's Gundaroo Creek, and then we've got Red Rocks Gorge in the ACT, which is absolutely spectacular if you have the opportunity to walk down there. So some of the issues we face, and I promise there'll be some better news towards the end of the talk, but significant erosion issues, whether that be from increased runoff or whether it be from a lack of ground cover due to stock accessing our waterways. It's a big issue because once sediment enters the river, it actually smothers all our fish breeding sites, and phosphorus is unlocked out of fine sediment, which then results in algal blooms. So there's a range of reasons why we'd like to lock that up in the landscape. The top right photo there is the top of the Boorowa River, or at least it was before we fenced it all off and revegetated it in 2006, I think it was, and I've got some photos of that towards the end of the talk too for comparison. Things like down in the left-hand corner, there's a complete lack of riparian vegetation, which means the water temperatures increase to a point where things like macroinvertebrates that hold up the whole food chain are unable to survive, and therefore complete loss of biodiversity. And other issues like crack willows. I know willows can be a very emotive topic, but actually it's not as black and white as it seems, because we've got so many different species of willows, and Canberra was the centre for introduction of those. And we've got some like Salix babylonica, or our weeping willow, which are all females. They don't cross with the males of other species, and they're really quite benign. whereas we've got other species like the crack willow, which in our smaller streams in particular absolutely just dominate that channel and trap sediment. And ultimately what happens is when you get a big flood, the banks blow out around them quite frequently. So that's a classic example of some of the issues with those. So willows aren't willows, as we're often led to believe, and it's worth having a look at your personal context to know what's the right option for management of those. Other issues, gullies have been historically used to dump rubbish in cars, and I still see that a lot when I get out and around the landscape. Up on the top right there, we've got gorse along the Yass River, which is one of my least favourite weeds, if people have a favourite weed. That one's just absolutely so difficult to control. Once it gets out of hand, it's a nightmare. Down the bottom left, we've got barriers to fish passage. So our fish often migrate tens of kilometres, if not hundreds of kilometres in some cases, and barriers to their ability to get to breeding sites is a major problem. That one's on the Boorowa, and most of the fish there are actually little flathead gudgeons and smelt and other smaller little fish that just haven't got a hope in hell of getting over a barrier such as that. Down the bottom right, we've obviously got some gully erosion, and so head cuts that are coming off the main channel of the gullies. They just continue to eat their way across paddocks and the like. And often it's usually due to groundwater. So the groundwater sort of keeps seeping through, and then when we get rain, overland flow then takes the soil away. So that's a continuing problem, at least in our part of the world, but I suspect probably everywhere. Then we've got things like the top left there, we've got a wetland that's got a head cut. And traditionally around the landscape, we did have these wetland areas in our valleys, and many of them were deliberately channelized to drain the paddocks to be able to graze or put in crops. So what we try to do then is to reinstate vegetation to try to ensure those processes continue, because they're great filtration systems. And in fact, we spend millions and millions of dollars on stormwater control, whereas just by keeping what we call a pediderm intact, which is the sponge underneath these wetlands, can actually suck up a lot of floodwater and reduce the expenses associated with stormwater management. And some of our developers are starting to see that and promote the protection of these pediderm areas. Top right, that's what I kind of call a cathedral, I suppose, cathedral erosion. It often looks a lot worse than it is, because by the time it gets to that stage, it's mostly reached its extent, and the soil loss then is caused often by rain. That fellow fenced and revegetated that big cathedral erosion. And then the bottom left looks really bad, but when we looked at the aerial photos from the 30s, hadn't moved 1 inch, because the base between the wall and the channel down the bottom is actually really stable and intact, and the sediment is made up of lots of small rocks compressed amongst the soil. So it's formed its own sort of wall, even though it looked, and we got called out there to look at that bit of erosion as a major issue. And then of course we've got things like dams. We need dams obviously for water supply for humans and other purposes, and they can be managed in a way where some of the impacts that we get at the moment are things like cold water pollution, where they release water from the bottom of dams into rivers, and that can have an effect for several kilometres downstream on biodiversity. So they're just some of the issues. Bit of a horror story. It gets better, I promise. The top left up there, we've got some more gully erosion, and that erosion is actually quite young. It's very narrow. We don't see that as much anymore. A lot of our erosion, at least in the southeast, occurred around the 1860s, where we had 3 1 in 100 events in a 10-year period. And because that landscape was being grazed or affected by rabbits, a lot of these gullies didn't have a chance to heal the way they normally would have, or the runoff was increased from a lack of ground cover and made it a lot worse. So some of the big old gullies, and you can really tell because some of those big old gullies have big 50, 60-year-old trees more in the base, so you can sort of get an understanding of when they occurred. Top right is obviously our algal blooms that most of us are familiar with from too much phosphorus in the water, where the algae grows to actually use up those excess nutrients. Down on the bottom left looks fairly nice, but there's absolutely no ground cover due to stock accessing that river. And you'll notice the river's a pretty turbid colour. As I mentioned, cattle like to stand in rivers and poo. And then the bottom right there, we've got a mixture of things like blackberries and a lack of vegetation on that creek. So the function there is very simple. It's nice to see the base of that creek actually growing over with some of the grasses, which is a good first step to reducing water flow and starting to reinstate some of the habitat for our water bugs and things that eat them. So there's some of the issues we've got, as I mentioned before, lots of different barriers to fish passage for fish. Some might just be a rock wall, and in some cases the natural rock walls have actually reduced the potential for spread of some of our feral fish species, such as gambusia, which is a mosquito fish, or carp. In the top of the Yass catchment, there's a creek called the Pudman Creek, and we have lots of little native fish existing, such as the southern pygmy perch. And there's a natural rock barrier which has prevented redfin and carp and other pest species getting up into that river system, which means that we still have fairly intact native populations. So sometimes it can actually work in our favour. And none of riparian management there's no black and white. It's not simple. It's about looking at the particular site that you're working on and determining what the issues are, and then having a look at some of the solutions, which I must say is a bit more positive. And we sort of work on the basis of a toolbox of options that have been developed over the last 25 years by various people, not just us. I mean, our first involvement, Shuan and I, was about probably 1998 when we started with the river care programs, and Land and Water Australia did a massive research and development science communications program on rivers, riparian lands. And so from a lot of work, we've actually been able to develop a toolbox of solutions. But before we get into those, I'll just give you some of the assessments that we do. For example, a good waterway has really intact canopy, overstory vegetation, mid-story vegetation and ground cover. It might be dominated by a rock, it might be dominated by more wetland species, but that's where we look at all the different elements and do an assessment of which bits are still there and which bits are missing. Now, the caveat on that is obviously a wetland. We don't tend to get overstory species in our wetlands, and so whatever assessment is made is usually based on a reference, what we call a reference condition site, which is a site that's intact. We know what it looks like and we assess against that. But then we also look at the actual function of that particular waterway, because it might have evolved to a point where it's not reflecting reference condition, but it might still be ecologically intact. So as I mentioned, it's not all black and white, but there are some simple basic principles. A river in this context where it normally would be forested is improving. We're lacking a bit of mid-story there. We have overstory eucalypt species, and we've also got a really good cover of things like the carex, which is the bright green plants that you can see in the improving picture. They're a great sedge for holding soil together. And then things like the poa-tussock, which also helps to slow down and filter water. So that one wouldn't take much to fix. That would just be a little bit of vegetation included and grazing management ultimately. And then a creek which we consider poor, has no riparian canopy vegetation. I think those might be poplars there. The impact they're having on the site would need to be assessed by actually going and having a look. And all of the grass species there, while they're holding the soil, tend to be a bit of a monoculture of pasture grasses. So, which is not in itself that much of a problem, but in terms of biodiversity and habitat for wildlife, having those big tussocks and the carracks and the reeds is actually preferable for most of our native animals, which are adapted to it. And so managing stock around waterways, obviously you have the opportunity to better manage stock, and some work that we did in Boorowa, we did a big river recovery project there. A lot of the landholders, irrespective of whether they saw an economic gain in terms of weight gain for stock or anything, all commented on the time management side of things, which was very valuable to them. So not having to get their stock out of waterways, making sure they had clean water, being able to muster stock more effectively, rated really highly in their responses to why they actually, you know, in terms of getting a gain from undertaking this work. So that was an interesting finding. So putting in crossings and laneways, using the riparian area as a focus to be able to manage the whole farm a bit better. Putting in alternative water, as I mentioned, that's the top right there. And those particular stock there have shelter as well as clean water. So I'm sure they're quite happy. Down the bottom, we attract things like wildlife for ecosystem services. So we attract then, by having that habitat, all of the creatures that help to keep our water clean. So all the water bugs, the birds that eat them, the fish that rely on them, the turtles, the platypus, water rats, a whole bunch of different wildlife that come back to our rivers. And then on the bottom right, that just shows a really well-developed riparian project where you can no longer see the river anymore. The shelter's immense for stock, and also when you walk down in there, there's a functioning system. So we're sort of, I guess that's the vision that we have for at least these particular rivers in terms of stock management. So this brings us, actually, I might just stop there. Has anyone got any questions before I head into the toolbox of options? Oops, there you Mitch. If you do have any questions, Shawan is monitoring the chat box. So what we might do is she can have a look at any questions that arise and we can answer those.
No chats at this, no questions at this stage, Laurie, so keep on going.
Okay, no problems. And we're happy to answer some of them at the end. So some of the toolbox, as I mentioned, some of the things that we employ, I think the biggest thing that we use to manage stock around waterways is obviously fencing. And when I say obviously, most people would assume that is the main way of doing so. But there are other options, things like installing water in paddocks, which attract stock to the cleaner water supply, can actually reduce pressure on creeks and rivers. So that's a lot less common than fencing, but in some areas like floodplains where fencing can't be installed, we do have other options. So some of these sites, so if you look at the two top left sites, the top left and the one below it is actually before and after, and that was only in about a year, a little over a year, just by putting that fence in has resulted in ground cover, and that has actually reduced the rate of that erosion significantly. And the next steps obviously is to put in some riparian canopy. But what we've found in our monitoring of our programs over years is that one of the fastest changes that we get is just the ground cover reestablishes, irrespective of whether it's pasture grass or native grasses, and it just locks up that sediment and gives you a basis on which to work. The top right two photos are the same sort of story, just a fence was installed, and in a short period of time, that ground cover has just created a buffer for runoff. And that's where we see, even if the stock, the other aspect, I mean, is that the stock are not standing in it anymore either. So there's a double benefit in that it's trapping nutrients, processing them, and we're removing a source of nutrients. People like Sydney Water Catchment, Water New South Wales as they're known, they are really keen to get stock off waterways simply because of things like disease, but then also often in our water supply we have problems with colour when there's a lot of sediment entering. So there's benefits for the whole community as well as on farm, obviously. The one in the middle is just a wetland area that was fenced off. And although we get a few things like weeds and in that case thistles growing, and I put that in there quite purposely, what often happens is we get an increase in some of our annual weed species like thistles due to a high level of phosphorus. So what they actually are doing is reducing the phosphorus levels, and frequently once you get good ground cover, they get out competed. There are things that can be done like mowing the seed heads off or in some way reducing their ability to seed. But what we see over a number of years is often those species drop out of the landscape. Some species like serrated tussock doesn't, it just keeps spreading. But often some of the, particularly things like dandelions and things that are naturalised, we're actually finding not as much of a problem as we initially thought. Although fencing off a waterway that is quite weedy, that obviously needs to be worked into any kind of management program. So down on the bottom left is the same gully, but the two photos don't match up. So when the fellow, you can see the fence down there is just falling into the gully. So that particular landholder decided to fence well back from the gully, and that picture was straight after he'd put the fence in. And you can see he's created a really nice wide buffer zone. And the purpose of that is he was going to occasionally crash graze that paddock, and I mean very occasionally, just and he'd never drop the grass down less than about 10 to 15 centimetres. But by having a wider area in there, it just meant it gave him more flexibility with his management. So otherwise, sometimes it can be perceived as fence it off and forget about it. And then often it isn't managed as a paddock, but by having it as a conservation paddock, you do actually enable yourself to be able to do some crash grazing or weed control or weed management. So that was the path that fellow took. And also the risk of losing his fence again is much more reduced. Some other fencing, the top left there is out at Burra, and that was in the face of lots of development. So as part of the development, that area was fenced off. And originally, because it was grazed, the response of the native grasses was absolutely huge. It was more than what was expected. And the other pictures are just other examples of fenced off creeks. And you can see the difference in the bottom left and the bottom right between the area not fenced and the area that is fenced, and that buffer zone that's created. In the case of the bottom right, it's got some beautiful pastures, a mixture of native and exotic pastures that landholder is utilising as a paddock, and then the riparian zone will provide shelter for stock, whilst also conserving the native red gums and things that are still there, which fencing is probably one of our most valued tools and forms part of that toolbox of options. So there's another photo there where the gully has been fenced off where it goes into a dam, and the idea of that is to keep the water in the dam clean. Another couple of examples. Sometimes now riparian widths always become an issue. So landholders are always saying, well, how wide do we fence? And really there is no rule, because some, as in that bottom right-hand photo there, some are much more narrow gullies. The erosion risk is low, and really you're looking at buffering or filtering the water coming down through that gully system. Whereas the top left there, that's a big swathe. It was once a swampy meadow. And in that particular case, that riparian fencing there is quite wide to enable a buffer strip. It's an area that in that actual gully there didn't have a lot of trees. So although it's been revegetated with some trees, they're retained on the upper slope, so that you end up with a beautiful grassy filter strip through the middle. So the width, I remember years ago it was always 20 metres. I'm not sure where it came from, possibly out of some research. But some of our floodplains are kilometres kilometres wide, and some of them are quite narrow. So again, we just assess on the basis of that particular circumstance. And some of these general principles, so rather than tell people what to do, trying to get people to understand the concepts, and then they can make their own decisions. And we've actually got a stream assessment checklist that through the River Restoration Centre, where you can actually go and look at your creek or river, and it's a tick box, very simple tick box to be able to do an assessment. So I'm sure Shawan will make that available to everybody. There's a beautiful grassy filter strip in Goulburn, and that area was once a chain of ponds, and the grass and the reeds are starting to just build up again to recreate that. So I know often we're tempted to plonk all sorts of weirs and things in that, but that particular site is doing it itself. And we've seen that quite frequently, particularly when the reeds build up and build up a bit of sediment behind them. It almost returns itself to a chain of pond system. I mean, obviously putting structures in would speed that process up, but also then you've got to assess the costs associated with that and any risks to adjacent banks. So again, it's what's appropriate for a certain setting. In that case, was the purpose was to improve water quality and start to build back to those original ponds. So some of the other tools are things like stock crossings. And as we mentioned, we keep coming back to the cattle pooing, but it is such an important issue. Managing stock around waterways with really well-constructed stock crossings can make a huge difference in terms of both management of stock and also the impacts on that waterway. So we find a lot of people that are involved with our source water project in the Sydney water catchment are really keen on installing stock crossings, and these don't have to be raised. In that top left-hand corner, obviously it's a raised crossing with pipes, but some of the other options are just simply to harden the bed of the stream, and if appropriate, fence either side of that crossing to enable you to funnel stock through the area. So it doesn't have to be really elaborate, but it just depends on what stock you have and what you're trying to achieve. Obviously, big rivers and things with high flooding potential need to be more closely designed than some of these. And Water New South Wales on their website have some really great information about designing stock crossings. So that's that might be on the ARC website as well. And similarly, farm dams, they've got some designs for those too. So some of the damage that our stock are doing in terms of better managing them, when I was talking earlier about putting in shelter for stock, there's been some great findings about planting things like acacias. So if you plan to manage your riparian area for stock shelter and through some crash grazing, by planting things like acacia, that adds an extra protein source, particularly for sheep. The research was done around sheep in relation to a project called Whole of Paddock Restoration. And what that found was that the sheep were actually in there hoovering up all the acacia pods, and this is worked through Greening Australia, and they were actually getting wormed. So that was really interesting. So once they found that, they sent off all the different acacias to CSIRO, who actually ranked them for their worm control potential. So things like the black wattle were actually quite anti-worm or anti-parasitic. And also not having bare ground meant there was a reduced risk of contracting those. So that work was done around barber poleworm. And just a really interesting finding and a little additional piece of information. Not obviously things like wattles. I know I've got landholders that don't like them, but there's lots of different types that don't all have to be tree wattles. And they also fix nitrogen in the soil to help the growth of other plants that are planted. So that's just a little bit of an aside in terms of stock management. These riparian areas can be well integrated into the rest of the farm to be able to provide a production benefit as well. And the bottom two photos just show some of the damage that stock do on our waterways in terms of reducing our riparian cover. So having accessible crossings for stock will alleviate this to a high degree, even in the cases where sometimes the waterway may not be adequately fenced, because they like to follow the path of least resistance. So if there's an easy way to get across, they'll cross it. So another tool is revegetation, obviously. This can take on many forms, but generally, I think we get sometimes caught up in the number of trees and the number of shrubs and grasses. And certainly when I used to work at Greening Australia, things were quite well designed in that regards. But we've just discovered over the years, as long as there's a good mixture of overstory and understory vegetation, mixing together, the actual configuration doesn't matter all that much. So you might like to have the entire creek revegetated, you might be doing stepping stone clumps, but if they're mixed up with all the different structures, they actually result in the same outcome by and large. So little birds, they don't like to travel more than 100 metres across a paddock or along a creek. As long as you sort of keep them closely enough together, you can actually do clumps where it's more practical. That picture on the left there is a mixture of trees and shrubs. I have a feeling it's a gully heading into the Waterway River, where the sediment, where it was eroding reasonably badly, and the sediment has been locked up, but then the habitat corridor that's created through revegetation there's really beneficial. And you can see that landholder there has got cropping and grazing either side of that. So when that increases in density, obviously that's going to provide a good buffer to the adjacent activities. The one on the right is just showing trees and shrubs growing there alongside that crop. And in fact, some work has shown, and I can't remember who did the work, but about 5 years ago, we learnt that carbon, the benefits of revegetation, the carbon extended for 20 or 30 metres into the paddock in the soil adjacent to this revegetation. So if anyone's really interested, I'll find the reference to that. But that really amazed me that soil carbon benefit extended so far out from the actual revegetation. Here's a few more examples. The two on the left, that's the Brindabella, up in Brindabella Valley. The top one's when the landholder planted, and the bottom one is about 5 years, actually about 3 years later. Along with that, all the crack willow were also removed from that system. They were impacting on the actual banks, and the river was starting to blow out around the big trees. In the past, we often would plant willows in the toe of banks, the bit where the wall meets the base, and that provided cover for quite a number of years. But as the trees grew into big trees, often what we're finding is that the river's actually blowing out around it because it's hitting a hard surface. And when it hits that hard surface, it deflects at 90 degrees roughly. So those were taken out. I believe the weeping willows were left in place. And over time, you can see down the bottom there that the native vegetation is taking hold. And just on that, I remember being at that site because there was this big fat wombat watching us plant, waiting for us to go away so we could mess up all the tree guards. So it wasn't without its challenges, but a bit of persistence paid off there. So there's tube stock planting, and there's also direct seeding. And I'm not sure how many people are familiar with direct seeding, but the direct seeder is towed along behind a vehicle, a ute, and it's got a plate that carves off about a furrow of about 10 centimetres, and seed boxes that drop big and small seeds in along the line, and then a press wheel that presses it in. And in appropriate areas where it's not too wet with too much competition, this works really, really well. So a lot of that more sort of drier slopes, and it costs about a quarter of what planting tube stock costs. So it's about $300 or $400 a kilometre compared to about $1,500 a kilometre. So in appropriate areas, that is incredibly efficient. And also natural selection takes place. So the trees and shrubs germinate where they're happiest. They put in a big broad mix of locally native species, and then they'll just come up as they like. The hard thing about direct seeding is you can't see it for a while. So planting a tube stock with a guard is very satisfying. Direct seeding, you've got to be patient and wait several months before you start to get those little plants germinating. But the overall results are really positive for direct seeding. It just doesn't it doesn't go well where there's high competition, like in Phalaris paddocks and things like that. It just struggles to compete. So applied appropriately, it's a really good method. Another tool is alternative stock water. So obviously if we're going to fence our stock off our water supply or our river, we need some options for alternative stock water. So the left-hand photo there is Isabel out at Murrum Bateman. She's putting in a trench for the water and she was setting up troughs. So often people will pump from the creek or the dam up to a header tank and then gravity feed to a variety of troughs. And this is quite beneficial setting up this system, although the checking and maintenance is higher than if you just had stock on the creek or stock on a dam. Really good flexibility to set up extra paddocks for better rotational grazing or to take certain areas out to give them a rest. So a lot of the landholders that we've worked with will use the incentives of the programs that we manage to set up a basic system, and then they will fund the installation of additional troughs and pipes and that sort of thing. Piping's quite expensive, so it just on what suits the nature of the project, but often there's often grant funding around that will help with this sort of thing, just to give people that a little bit of a help along the way. It never covers the full cost, of course, but it does provide a bit of assistance. There's a picture of a trough up the top of a hill there, and they were trying to, in fact, that particular property were keen to conserve their dam as wetland habitat for birds, and because they really loved having the wildlife, and so they actually installed alternative water to be able to fence off dams, which you do see more and more these days, although people still use dams quite a lot. Most people put in water to fence off a creek or a river, but that's just another innovative use of water in terms of habitat. So some of the structural works to look at erosion control. So 95% of sites will respond, eroding sites will respond just from fencing. Getting that ground cover back, as I showed you earlier, and buffering some of the activities adjacent. But in cases where the erosion is unlikely to stabilise just with fencing, we have a range of structural works at our disposal. It can be anything from putting a few rocks in, is that middle left photo there? It was just a matter of putting some rocks into a gully. The flow was very low, so there wasn't a risk of losing those rocks. And any kind of installation of rocks in a gully needs to be big enough to withstand the flow. Top left-hand corner there, that was underlain with a geofabric called bitumen, and that just stops the undermining of that rock structure. So you can get that at Fishwick. I think it's A24 bitumen if anyone really wants to do some erosion control over the weekend, but it just stops that undermining of the soil. Things like rock armouring on the right-hand side, there's a before photo at the top and an after photo below. That's where the toe of the bank absolutely will not stabilise, and the force of the water continues to hit that outer bend. And you often get that in some of the smaller creeks where water flow has increased in a catchment. Sometimes from urban development, the more concrete surfaces will actually increase the flow and reshape the creeks below lower parts of the catchment. So the softly approach is preferred, but in some cases we do need to armour toes of banks and things in association with fencing and revegetation. That big gabion rock structure in the middle with the date underneath it that says 2000, that whole structure actually went into flood at one point and had to be rebuilt. And it was a big mesh structure, and once the water got in under that, it took the whole thing. So the force of some of these creeks cannot be understated. I think that was rebuilt with free quarry rock in the end, because that's Jerrabomberra Creek, and the reason for that is a lot of the Jerrabomberra Creek catchment, which is to the, I suppose, the southeast of the ACT, a lot of that catchment's being developed now with new suburbs, and so then the water flow has increased to the point where our original structural plans would no longer be sufficient. But because that was part of that development there, they obviously had resources to be able to rebuild it, but better not have to do it twice. Earthworks we use very rarely. Some sites still warrant it. Generally, it's the construction of banks around head cuts, like in that top right photo, where rock armouring those and constructing a flume is just too much rock. It's too much disturbance. And so in that case, you can see a faint bank around the top of those two head cuts where they actually move water off those and drop them down further down the gully. Now, the issue with this is sometimes when we concentrate water and drop it somewhere else, we start a new problem. So earthworks is very much used sparingly. And also, as you can see down the bottom, even in the construction of the works, it can be quite a huge amount of disturbance. So it is still used. Soil Conservation Services still do a lot of this work, but it's applied very, very carefully. And then our rock flumes, these are my favourite. Well, there's concrete and rock, but basically we're just laying rock down in a flume to reduce those head cuts, as you can see in the top right. So the top right is what it looked like beforehand, and the top left is after the flume was constructed, and then it just takes time to regrow vegetation. And the purpose of any of this work is to get grass to grow, basically, and vegetation to lock soil up. The structural works that we do are not the end game. It's about stabilising soil enough to get vegetation to establish. And in catchments with really, really high flow, we often concrete will be used. It's not as flexible as rock, but where the flow is enough that the rock can't be big enough, can't obtain big enough rock to actually stay in place, concrete may be used. And you can see the bottom right there, that's the end result of the top right and the top left after some of the vegetation had grown. In that case, we left the poplars in place. They were a bit historic and they weren't really spreading, and that landholder liked them. And then the next step would be to promote planting of native vegetation. So it's a little bit of a process, but some massive flows come down through that gully. In-stream works we use sometimes, actually this is expanded a little bit now to include things like fish hotels that are being put in place for fish to breed on where rivers are really silted up. But on the top left there, they're called groins, Groynes, rock groins. And the idea of that is you put a series of rock groins around an outer bend. When the water comes through, as I mentioned earlier, it hits a structure and then gets deflected at 90 degrees roughly. And that pushes that channel, the flow back into the centre of that channel. That system works extremely well on wide rivers. In a small creek, that's not as effective because you obviously erode the opposite bank. But in a system like that on the New Morella River, it's been very effective of getting the river to move to the centre of the channel and take the pressure off that outer bank. Those on the right, sometimes it's impossible to get machinery into places, so you might just carefully construct some stabilising, whether it's rock or whatever materials it is, just to enable the soil to stabilise enough to get that tussock cover that you can see in the below right there. And then there's all sorts of gabions and things that can be put across gullies, particularly where the flow isn't too high, and that can actually build the base up. So that's useful where the base of a gully is actually going downwards, resulting in a widening of the gully. So people can get quite creative with some of the options that there are to stabilise areas. And in more recent times, we've got things like leaky weirs, which can help to reinstate chain of ponds in those really flat valley floors where we've actually channelized some of the wetland area. It doesn't work quite so well in the steeper parts of the catchment, simply because the size of the structures required to not flow or get washed away and flood, the cost will often exceed the outcome. Often the soil types quite different. It's a better draining soil compared with a swampy meadow where the water can stay locked up in that system for a lot longer.
All right, just so you know, we've got about a couple of minutes left for your talk, so we need people to be able to ask some questions as well. But I mean, we are happy to run over to 12:30, but I'm conscious some people may need to leave.
Oh, that's all right. I'm nearly finished. So as I mentioned earlier, willows can be an emotive issue, but we just step back and say, well, what are they? What species are they? Things like crack willow just spread and spread and spread. Every little bit that breaks off will spread. Then we've got our other seeding willows, like our black willows, which just take over entire areas of sediment. And then we've got our species like there's a subspecies of pussy willow, and there's our weeping willows, which really are quite benign. They don't do much, and they often look quite nice as well. So leaving those as part of a willow control project is not uncommon. Some people are on the other side of the coin and want all of the willows gone. So it just depends where you're coming from. So we take the emotion out of that whole management side of things, and we look at the stream, what the willows are doing, and whether they actually need removal. Do they need removing, or can they just be stem injected and left in place? All of those sorts of things are considered, and then also the follow-up control required, because if you've got a machine in, every little bit that breaks off can grow. So there needs to be a follow-up program. So in examples of Waterway River, where there was 27 kilometres of willow control undertaken in association with fencing to protect remnant vegetation, revegetation, alternative stock water, and using CSIRO, they've done a lot of work on water use of willows. Willows use about 4 times the amount of water as a river red gum. And that was actually determined by using loggers on trees, as well as looking at research in irrigation channels where all the parameters were fairly similar. And so by measuring the crown canopy in hectares of the willows that were removed, about 87 gigalitres of water was returned to the Boorowa town water supply during drought, which is about a quarter of their supply. So obviously if it's raining, that doesn't matter very much, but in drought, council were very keen on looking at these figures, just because that's significant. The reason that is because the Boorowa River is an ephemeral stream that contracts back to little ponds, and the willows were sucking a lot of these ponds dry. The reason for doing that work was the landholders. So they were unable to access their river effectively anymore in places, and so they all got on board. There were 19 of them to undertake this work, but that importantly required 8 years of follow-up every 2 years by the contractors. So it's really, really important. Otherwise, we often see actually now work that's been done 15 years ago is regrowing again, and there's very little resources to help people to manage that. So the willow issue is not a straightforward one, and it's one that needs to be thought through carefully. Also, what you do with all the debris. The debris will obviously need to be removed so that it doesn't impact on infrastructure downstream. So there's a nice little snapshot of before in the top left there with absolutely no cover, 2 years down the track, and then 5 years down the track on the bottom left. So you can start to see the shelter being put back in that paddock, and also the stabilisation of that little creek. There's a photo of river that's just been protected. So nothing else has been done to that. Stock are removed and we're starting to get our riparian vegetation, particularly that carex that I talked about earlier, the bright green plant, starting to re-establish. And all of this obviously can be worked into a farm plan. And so that's what we would promote, is that it's not just fencing off the creek or the river, it's actually working out paddock locations and water supply, and using some of the grants that are available in various parts of the country to be able to start to integrate the conservation and water quality management with production. So none of this would happen without all the people that we're working with. These are just some of the farmers. I won't go through them all because I know we've got a time frame, but these people are all doing things like Margie's fencing off massive erosion gullies. Gary's protecting his waterways out there at Crookwell while he's growing his potatoes. Matt Doyle has been working for years and years and years around the Yass region and has nearly got 30% of his property revegetated along with his creeks and rivers, and he's actually fenced off the top of the Burrawa River that I showed you earlier, and it's protecting that for the community. So, and Matt's actually seen no impact on his production because he's now got shelter and a lot lower land losses just by installing that shelter. So he's got a really well integrated project. All of these guys you can read about in the Stock and Waterways guide as well in detail if you're interested. Another few families there installing solar alternative water there on the right to take stock off their waterways. And it's all the way that Shawan and I work with Rivers of Carbon and the River Restoration Centre is by putting people first. It's all about the social side of things, and then we just apply our toolbox of options in partnership and in the context of integrated sustainable farming. So I might leave it there. There's the picture of the Stock and Waterways guide that's available for people. There's a hard copy, and there's also online where you can just download chapters. So it's all in, our toolbox is all in chapters, which people can access.